Hi, everyone. My name is MacLane Wilkinson. I am one of the co-founders of NewCipher. NewCipher is a data privacy layer for blockchain and dApps. We give developers a way to store, share, and manage private data on public blockchains, or more specifically, file systems like IPFS or Swarm. So for example, let's say you're building a healthcare application, you want to store patient medical records on Swarm or IPFS. We give you a way to have those be private, confidential, and encrypted, but importantly, still have those encrypted records be shareable with a valid recipient, say a doctor or a hospital, for example. So I'll go into a little bit about the architecture and how we built this in a second, but just to start, I'll give you a few examples of the types of things you could potentially use NewCipher to build. A very obvious one would be a sort of decentralized, end-to-end encrypted shareable Dropbox. So you have files, whether they're medical records or photos, you're encrypting them client-side, uploading them to the storage layer. At that point, you're the only one, obviously, who can access those files with your own private key. But using NewCipher, you're able to easily delegate access to those files to your family, to your medical records provider, to some third-party service provider, without having to share your encryption key and without ever exposing the files in plain text to the storage layer. Oops. Another very interesting use case would be being able to create very scalable and performant end-to-end encrypted group chats. This is actually a challenging problem even in a centralized context, much less the blockchain space. The reason being it's very performance hungry to encrypt a message for each participant in a channel. When someone new joins a channel, you have to encrypt the entire history for them. Every message that someone sends needs to get encrypted n times for each participant in the channel. So this is one of the main reasons why these giant 10,000 person Telegram group chats are not encrypted. It's all in plain text, is because it's extremely expensive to do that encryption. Folks like Signal will use something called double ratchet encryption to try to do this, but at large group sizes, it still gets a little bit clunky and messages will appear out of order and things like that. Whereas with NewCipher and our underlying proxy re-encryption technology, you can really easily do this, just delegate access to as many recipients or participants in a chat as you like, and then easily revoke access, say, let's say if you need to boot someone, for example. You could also use NewCipher to create conditional decryption. So for example, creating data exchanges or data marketplaces. In this case, creating a decentralized Netflix where you're streaming encrypted video and you're only giving people access in exchange for payment. So by default, it's encrypted for the data owner, but you can embed in a smart contract some condition that says allow the recipient to decrypt if they pay 5, 10, or however many ETH to your address. And of course, how we solve this sort of data integrity or data confidentiality problem in the centralized world with things like TLS or encryption in transit. But fundamentally here, you're still trusting the service provider. So if you're using Dropbox or Gmail, I probably don't need to tell any of you guys this is why we're kind of in the space, but you're fundamentally trusting that provider. And maybe it's fine to trust Dropbox to store your servers, to store your files, or to trust Gmail to store your emails, but perhaps you don't want to trust some of the people that are trying to hack into them. And then of course, if we extend this to our space, in the decentralized context, having everything exposed plain text server side is a complete non-starter. These are not nodes that are sitting in Facebook's data center, in Dropbox's data center. These are nodes that we have no idea who's operating these nodes. They could be in Iran or Russia or wherever. What we've done, proxy re-encryption at NewCipher to solve this is combine two core technologies. One is something called proxy re-encryption, and the other, of course, is decentralization using the Ethereum blockchain. And we basically created a decentralized key management service. And I'll sort of build up to how we've constructed this system, but piece by piece, proxy re-encryption is a more scalable form of public key encryption that allows you to delegate access and revoke access to arbitrarily as many recipients as you like. So if you think of traditional public key encryption as being very good for one-to-one communication, so let's say I have some secret message, I need to share that message with one of you in the audience. I can just encrypt with your public key, send it across the network, you decrypt with your private key. It works perfectly well. But let's say now I need to share that message with dozens or hundreds of people, everyone in this room, everyone in this conference. It just starts to scale very poorly. I have to encrypt n times for each person, send it across the network a whole bunch. Whereas with proxy re-encryption, I can just encrypt that data one time under my key, and then use something called a re-encryption key to transform or rekey or re-encrypt that data for a recipient. So you could imagine just building a traditional centralized key management service using proxy re-encryption as sort of a primitive, where you have some original data owner, an intended recipient, a storage layer, and then some proxy that's going to perform this re-encryption. So the data owner will, of course, just encrypt their data client side, upload it to the storage layer. Let's say at some point in the future they need to grant access to the recipient. The data owner can create something called a re-encryption key. And this re-encryption key consists of two inputs. One is the data owner's original private key, and the second is the intended recipient's public key. And creating this re-encryption key is a one-way function, so you can't extract the private key back out. The data owner will give this re-encryption key to some semi-trusted or untrusted proxy, and then the proxy can use that re-encryption key to re-encrypt or rekey or transform the data so that it's now encrypted for the recipient, at which point the recipient could just use their own private key to decrypt the data. And during this entire process, you are never exposing the data to the proxy. You're never exposing the data to the storage layer, just the original data owner and the recipient. We've taken this kind of a step further for the purposes of blockchain and dApps and created a threshold split key re-encryption algorithm. So instead of one re-encryption key, we split that re-encryption key up into a bunch of shares, issue those out to the new Cypher network. The new Cypher network consists of many untrusted proxies which perform this re-encryption on the data owner's behalf. And the nice thing about this is you're not having to trust one single proxy to do this re-encryption. So if a proxy goes offline, you still have a quorum of proxies to re-encrypt. If any one or however many proxies is malicious, it's not a problem because your data will still get re-encrypted. And this threshold is tunable, so you can set it to 30 of 50 shares or nodes must come together in order to re-encrypt, 3 of 5. It really depends on your use case and your threat model. And the nice thing about this is it's an entirely trustless, decentralized, non-censorable key management service. So you're not having to trust Amazon Cloud HSM or Azure Key Vault or HashiCorp Vault or even NewCypher for this. A little bit more on this split key re-encryption algorithm that we've created. We call it Umbral, which is Spanish for threshold. It was jointly created by our company as well as a proxy re-encryption researcher at the University of Malaga. And different proxy re-encryption algorithms have different characteristics or properties. So ours happens to be unidirectional, which means you can re-encrypt data one way. So you can grant someone access, but it's not reversible. So that person can't, for example, write back to the data. If we were to have bidirectional, you're potentially opening the system up to certain vulnerabilities. It's also single hop, which means I can delegate access to you, but you can't then forward that along to someone else or re-encrypt it again. And finally, it's non-interactive, which means the two keys that are involved are the data owner's private key and the recipient's public key. There are interactive versions which require 2 private keys, but in our case, it's just a private and a public key. We basically use key encapsulation and data encapsulation. So we're basically encrypting the bulk of the data with a symmetric key. By default, it's SHA-20, but if you have some specific regulatory requirements, for example, if you need to be HIPAA compliant, you can easily swap this out for AES. And then we encrypt that symmetric key with our key encapsulation, and that's where we do the actual splitting and re-encryption piece. The system uses, to ensure nodes are basically re-encrypting correctly and behaving correctly, we can do verification of that through non-interactive zero-knowledge proofs. This piece is still kind of in development, so it's not fully built out yet. But you can just explore the cryptography library. It's on our GitHub org at PyUmbral. We've also got docs up as well. Finally, we have an ERC20 token, and the purpose of that is if you want to be a node in the new Cypher network and basically provide re-encryption work to the network and to users, you have to stake that token as a kind of collateral or security deposit. So we use this for a couple things. One, to allocate work. So if you're staking 10% of the tokens, you're getting 10% of the re-encryption keys. You're providing 10% of the work. You're getting 10% of the mining rewards. And we also use it as an economic incentive to ensure that nodes are behaving correctly. So if you are a node and you're going offline for extended periods of time, or instead of properly re-encrypting, you're just spitting back garbage, someone can challenge you, provide a proof, and your stake will get slashed. And if you are running a node, the incentive for that is sort of twofold. One, users will pay to use the network in ETH. So you'll have that income stream. And then also you'll participate in our inflation schedule, depending on how long, proportional to the amount that you staked, basically. A few examples of some of the early users of NewCipher. One vertical for us is decentralized data exchanges and data marketplaces. So projects like Datum, which are aggregating a bunch of different kinds of data. It could be browsing history, social media data, genomics data. They're encrypting it, putting it on IPFS or Swarm or some decentralized file system, and then conditionally decrypting it in exchange for payment. So selling, giving regular people a way to monetize their browsing history by auctioning it off to advertisers, selling genomics data to researchers, for example. Several of the decentralized databases that have been cropping up, like BlueZell or Fluence, are using us as the access control layer. So to control who can and can't query their database. And then another very popular use case is a lot of these healthcare portable medical records projects like MediBlock or Medicine or Wholesome.io, which are giving users control over their medical records and then the ability to easily move between providers. If you'd like to learn more, obviously we have all of our development open on GitHub. We also do all of our development discussions on Discord, so we're happy to have you join that. We have a more technical and scientific white paper available on Archive or on our website that goes into obviously much more detail than I can cover in the relatively short amount of time we've got here. Obviously very interested in speaking to any of you if you're interested in potentially doing peer review or contributing, as well as if you have a project that could potentially or has a data privacy, data confidentiality problem. Hopefully we could potentially solve that for you. And my email is just MacLane@newcipher.com. Thanks very much, and happy to answer any questions if there are any.
Thanks for the talk. That was really interesting. Just curious if you had explored ways in which you can use your network to help people kind of regain access to funds. One of the biggest problems we have is people losing access to their keys, and yep. It strikes me that you're building stuff that could really help with that, which is really interesting.
Yeah, I mean, I could imagine using proxy encryption as kind of a primitive to construct some sort of more sophisticated passphrase recovery system or something like that. We have a few projects that I think are in the early stages of kind of exploring that. There's also this interesting property that we're not actively working on at the moment, but the sort of the inverse of proxy re-encryption, which is proxy re-signing. So you can delegate authority to sign, potentially a transaction or something, on your behalf to some third party. So you can imagine potentially it's like a custodial service being built using that, or people delegate access temporarily to an exchange in order to transact without having to give the master key to that exchange, for example.
Another question, you talked about that you can share access, you can give access to people. Can you revoke it from a couple of them, or do you have to revoke from everybody?
Yep, so one re-encryption key targets some specific recipient. So you don't create a re-encryption key and that re-encryption key can re-encrypt for everyone in this room. I would create a re-encryption key that targets one person in this room. And then if I needed to give more people access, I create additional re-encryption keys. So I can basically issue a revocation command to the NewCipher network and say, hey, tell the nodes that have a key share of that to delete their share. So you can revoke to a certain extent. Once the recipient has like downloaded the data, decrypted it, has it in plain text, we don't solve that problem. But if they haven't done that yet, you can revoke.
Hello, thank you for your talk. I have a question about delegation access for other people. For example, when you have data storage on IPFS or on Swarm, why not to use just like Diffie-Hellman, like key exchange, and then have like some session key, and then they have access to that key, and then at some point revocate the key, yep. Or like why doing this? And also a question, well, if they have access at some point, well, even if you revocate the access later on, since they have the history, they could download it. So by revocating it, they only don't have access to new data, but the one that was already downloaded, it's, even if you revocate access, it's meaningless.
Yeah, so if, to take the last part first, if the recipient has downloaded the data, decrypted it, and saved it, we don't, that's not part of sort of the piece we're solving, we're just the initial access control piece. So you can revoke if they haven't already accessed the data, or if they've accessed the data but haven't saved it. But if they saved it, obviously that's sort of out of our control. It's plain text data at that point. And then the first piece, the advantages of this system are, there's a couple things. One, once you've delegated access to someone, the data owner can just go offline, so it's not requiring them to be online to sort of establish a session. And then secondly, you can use smart contracts to embed conditions into sort of the access. So you can say, only grant access to this person if they pay 5 ETH to my address, or only give them access between X and Y time, or potentially, if we have working oracles at some point, you could make it contingent on real world events. Thank you.